In this problem, once again, we're going to be working with the ideal gas law. And the question reads as such. A sample of Freon 12, which is CF2Cl2, occupies a volume of 25.5 liters at a temperature of 298 Kelvin, whose pressure is going to be 153.3 kilopascals. Pascal is a different kind of unit than what we're dealing with, so we're probably going to have to convert that, is what I'm thinking. We need to find the volume, so we're looking for V2. That's what we're looking for at STP. So what STP stands for standard temperature, standard pressure, and that temperature is 298 Kelvin, and the pressure is going to be 1 atmosphere. So right now we see we got a little bit of an issue. We got a pressure that's going to be at 153.3 kilopascals, and then we got a pressure at 1 atmosphere. So we're going to convert the kilopascals into atmospheres. And to do that, we're going to be using a conversion factor, and that conversion factor is 1 kilopascal, oops, forgot the P, is equivalent to 9.87 times 10 to the minus 3 atmospheres. And when you do this arithmetic, what we end up getting is we get that our pressure is 1.513 atmospheres. So that's going to be P1. That's going to be P1. Now, we're going to go back and use the equation we've seen before, where we have P1 V1 all upon T1 is equal to P2 V2 all upon T2. Now, we know that T1 is equal to T2, right? So we know that we have the exact same temperatures. So our temperatures cancel. We end up with P1 V1 is equal to P2 V2. All right. So now we can start plugging in our information. Remember, we're going to put our pressure in for atmospheres, not kilopascals. So this is 1.513 atmospheres times our volume, which is 25.5 liters, is equal to P2, which is 1 atmosphere, times V2. So we'll solve this for V2. We can divide this whole thing by 1 atmosphere. Atmospheres cancel. And our V2 for this problem is going to be 38.58 liters. And so if we have a sample gas whose volume initially is at 25.5 liters and a temperature of 298 Kelvin and a pressure of 1.513 atmospheres, see, we converted this from kilopascals into atmospheres, and we're going to go to STP. The volume of that Freon is going to be 38.58 liters. If you have any questions on problems similar to this, please let me know.